So in this video, we'll go into more details about the rethinking of aging. It is part one, a new perspective on mechanism and strategies to slow down and reverse aging. As always, I recommend you to download the presentation from the link in the description, and then you can get access to source of information, to the references, and to the links in the text, and you can do your own research. Don't rely on me because I am not medical professional. I have a PhD in physics and mathematics. My biology is my favorite, but yet I am not supposed to give you medical advice. And so what I do is I do this research for myself, and with the purpose to not only slow aging but to live maybe up to 1,000 years young and healthy. Okay, let's go. The mainstream research on aging is mostly focused on cellular damage and loss of physiological integrity of the organisms that happen over time. 12 hallmarks of aging were proposed. It is a genomic instability, telomere attrition, epigenetic alterations, loss of proteostasis, deregulated nutrient sensing, mitochondrial dysfunction, cellular senescence, stem cell exhaustion, altered intercellular communication, disabled microautophagy, and okay, cellular senescence. I make it twice. Sorry, it's okay. But anyway, and dysbiosis. Followers of my YouTube channel know that in contrast to mainstream research, I consider aging as a consequence of stiffening of the extracellular matrix, which leads to compromised ability of the immune and stem cells to maintain the proper functioning of the body and the development of chronic hypoxia in tissues. While accumulation of junk inside and outside cells is also going over time, it is not main cause of aging. We can handle it. Yeah. So again, my viewpoint is very different from dominating viewpoint of other researchers, and I believe I am right and they are wrong. Okay, whatever. So this is how I think extracellular matrix looks like. It is a frame of collagen and elastin fibers which support our the cells and shaping our body and organs of our body. But over time, it is stiffening due to reactions of these protein molecules with sugars. So what we can do to rejuvenate it, it is that we have to rejuvenate extracellular matrix in particular. But again, it's not very easy task. Epigenetic clocks such as Horvath clock, based on measurements of DNA methylation level, were proposed about 10 years ago. Various methods of epigenetic rejuvenation were developed, such as following: cellular reprogramming with Yamanaka factors, clearance of dysfunctional cells in the state of senescence, and decreasing production of by senescent cells, pro-inflammatory signal molecules known as senescent-associated secretory phenotype, and then next, stem cell therapy, which may include sourcing stem cells from various sources, cultivation of them in vitro, and transplantation into a human body. Drug-induced production of stem cells in vivo in the human body, particular, and reduction of this concentration of this SASP molecules in the human body by young blood and plasma transfusion. So it is like diluting this blood by transfusion of young blood, and also reversing the thymus involution and regeneration of bone marrow, to increase the number of blood and immune cells in our body. Okay, this is again, this is how Horvath clock works. So it is considered that DNA gets methylated, but the level of methylation is increasing over time. But again, if I look at this methylation, and then you see here a representation of levels of methylation versus age. Age is here, and this is level of methylation in different tissues. And if how people can derive age, biological age from methylation level from this data, it is something above my understanding. So I would never rely my experimental data on such uh, on such. Yeah, it's just impossible. You can do it so, or you can do so. Why it is so? Why? So I would never accept this horrors, epigenetic clocks, and I would never use them because it is again it is kind of scam. Okay, whatever. But what is important? This the thymus involution. Thymus involution is really happens. So it's not only size of thymus is changing over time, but it's also fat accumulates in the thymus, and then the idea if we can rejuvenate thymus, it means to reduce amount of fat cells in the thymus and increase the size of the thymus. It can be so we can improve function of our immune system, and it can be related to rejuvenation. Okay, it's interesting idea. So there were a lot of research on it, and you can click on this slide, and you can go to this to some presentation which is related to the thymus rejuvenation. So let's go through them. So again, in contrast to the mainstream research, instead of these Harvard clocks, which are absolutely not reliable to my opinion, it is again I hate it. I would never use it, but whatever. So I in contrast to the mainstream research, I propose using of markers of related to the age-related tissue remodeling and tissue functions, such as blood pressure and pulse pressure. Pulse pressure is difference between systolic and diastolic blood pressure. Resting heart rate and heart rate variability. So vital capacity of the lungs, so it is the volume of air we can inhale and exhale, and breath holding duration, which is his name static apnea, and age-related changes in the level of intelligence quotient, so it is related to your cognitive abilities, lean body mass, waist circumference, and body mass index. Okay, this is some maybe not much reliable as a factor of aging, but nevertheless it is normally over time people accumulate fat. So next, muscle strength and endurance. Sleep duration and quality, again you can use it to estimate your aging. Yeah, so people sleep shorter over time. And also skin elasticity and development of deep wrinkles. This is visible signs of the age of aging. Estimations and measurements of these parameters are affordable for almost anyone. Then necessary changes in the diet, physical activity, medications, treatments, and procedures can be implemented to achieve functional rejuvenation. Not reliable, not this hover clock estimation, but really functional rejuvenation. Really, also even your appearance you can estimate is it improving or not, but it goes slowly. But this, for example, pulse pressure is very quickly relatively quick react to changes in your diet and your your physical activity. So I rely on pulse pressure. This is the main, and the resting heart rate also very important. Slow heart rate is actually indication that you are good and you will live longer. So okay, nevertheless, reversal of the immune system aging is important because again, immune cells are migrating, and immune system keeps maintain our body. So the reversal of the aging of the immune system is important. We have to think what to do with this, and we can rejuvenate it certainly. And let's dig deeper into this subject. So this. Again, this is how I imagine for myself this extracellular matrix, and it is again cross-linking with sugar molecules getting stiff, and so it's getting remodeled, and then then what is happening, that fibrosis, eventually fibrosis develops. It is fibrosis of tissues. Tissues are getting very stiff, and immune cells and also stem cells cannot migrate, cannot keep maintenance of the body. So multicellular organisms are merely colonies of cells in a state of functioning, growth, division, and this is the colony is supported by the extracellular matrix as a frame. While some cells continue to grow and divide, most cells differentiate and cease to divide. The cells which retain the ability to divide may become senescent and eventually die or be eliminated by the immune system. Normally, again, in younger age, senescent cells appear and they are quickly eliminated by the immune system. In active functional cells, accumulation of junk material is inevitable. It is again, this junk is, but various kind of junk. So when cells die out, the junk material accumulates in skin and tissues between the cells. One example of such accumulation is lipofuscin granules, often referred as age pigment, which build up in a variety of mammalian tissues as they age, but also in skin. And these granules contain oxidized unsaturated lipids from cell membranes that are cross-linked with other lipids and also with proteins, with denaturated proteins. While lipofuscin granules in tissues typically do not directly harm cells, excessive accumulation of lipofuscin can interfere with cellular function. So again, these age spots very visible on skin of old people, and so in contrast with young skin. Okay, this is age spots. Okay, what we have immune system and how immune system produce immune cells and how it keeps the maintenance. It is quite complicated system, and again we have to pay attention and what we can do to rejuvenate and improve function of the immune system. Lipid peroxidation within cell membranes is an ongoing process in all living organisms. This is again just normal. Some oxidized lipids are metabolized, but those that cross-link with other molecules, which includes protein and other lipids, they may persist. The composition of the membrane, antioxidant level, and oxidative stress in cells, specifically in the mitochondria, all affect the rate at which this build-up occurs. Okay, mostly reactive oxygen species produced in mitochondria, and also the membrane of mitochondria is first to be damaged by this reactive oxygen species. So, and this oxidized lipids and damaged mitochondria. This is what we see in what leads also to this dysfunction of the cells. So cells can mitigate some of the damage by expelling junk and damaged cell components through extracellular vesicles. I was talking before, but again, extracellular vesicles. Stem cells, these are small, they just expel outside the components that they don't need. Stem cells can change into various types of cells and proliferate indefinitely. But how they do it? They must maintain themselves in healthy conditions, and asymmetric cell division plays a key role in this. When cell divides asymmetrically, one daughter cell gets the majority of accumulated debris on this junk and damaged mitochondria, making it mortal. So it is again, stem cells produce mortal cells, and also they produce stem cells. So while the other daughter cells is rejuvenated, and they will continue to stay stem cell. Okay, so as again I said, mitochondria, they produce reactive oxygen species. This reactive oxygen species, they damage membrane of the mitochondria, but also they damage DNA, and this is very dangerous. And this is also a cause of aging and principle. So what we have, if somatic cells go to symmetric division, then we have two cells, so it can be stem cells or somatic cells, and then equal distribution of some junk material and damaged mitochondria between the daughter cells. But normally if stem cells are healthy, then we have asymmetric division. Asymmetric division that all junk material and damaged mitochondria go to cells which will further differentiate and they will become somatic cells, but stem cells continue to rejuvenate, to expel all junk, to expel all the damage, and they stay indefinitely young and in our bodies. So the researchers discovered that during asymmetric cell division, there were almost 6 times as many damaged mitochondria in daughter cells that were going to differentiate eventually to somatic cells, compared to daughter cells which were going to remain stem cells. This asymmetric splitting of cellular components between the daughter cells may represent a mechanism through which stem cells prevent accumulation of damage in their lineage over time. Further, researchers discovered that disrupting the cell's inherent mitochondrial quality control mechanism prevented asymmetric cell division and sharing of young and old mitochondria. So between this between this in this asymmetric division, and also it causes loss of stem-like characteristics. In organisms, the ability of stem cells to divide asymmetrically and distribute damaged proteins among daughter cells again asymmetrically decreases with age. This happens with over time. Age-related blood artery stiffening compromises the bloodstream ability to transport oxygen to tissues, which can lead to development of chronic hypoxia. This, again, to my opinion, the stiffening of extracellular matrix and in particular stiffening of the blood vessels, this is main cause of aging. So it leads to chronic hypoxia. And chronic hypoxia leads in turn to excessive production of reactive oxygen species by mitochondria, high oxidative stress in cells, and increased cellular damage. High oxidative stress contributes to the misfolding and aggregation of denaturated proteins in cells, and in particular then when it is happening in brain, for example, some aggregates of denaturated proteins in cells can be some aggregates can be degraded by enzymes and in lysosomes, but not all. Under chronic oxidative stress, oxidized lipids and lipoproteins aggregate inside the cell, and then aggregates of these denaturated protein molecules and defective mitochondria and other junk materials such as which has name like lipofuscin or it is similar lipofuscin, but again aggregates of proteins, they accumulate in active cells and then pushing cells towards senescence because they cells cannot function properly. This is how senescent cells try to expel damaged mitochondria and some junk material, and they produce these extracellular vehicles. But this junk material is changing other cells. They ignite senescence in other cells. They work as signal molecules. So somatic cells such as fibroblasts can divide symmetrically only a limited number of times, typically about 50-60 divisions before they reach an Hayflick limit. Okay, you can go over this. It is related to telomeres. Once this limit is reached, the cell either enters a senescence phase or die. Genetic manipulation using Yamanaka factors have been shown to extend the symmetrical division capacity of somatic cells indefinitely and promote energy production through aerobic glycolysis. Aerobic glycolysis in cells produce fewer reactive oxygen species, minimizes oxidative stress, and thus decreases cellular damage. However, this genetic manipulation also carries the risk of turning these cells into cancerous cells. Yeah, this is the danger. Aerobic glycolysis is linked to the Warburg effect in cancer cells that shift the energy production from oxidative phosphorylation in the mitochondria to glycolysis in the cytoplasm. So, by relying on glycolysis, cancer cells generate fewer reactive oxygen species. They are minimizing oxidative stress and thus decrease cellular damage and the risk of apoptosis. So this is how they survive, by changing from oxidative phosphorylation to glycolysis. But if you do it with Yamanaka factor, then cells may become cancer cells, and then they will divide and grow indefinitely. So recently, research has been focused on partial cellular reprogramming using Yamanaka factors again to turn differentiated somatic cells into induced pluripotent stem cells. Okay, this is a little bit deeper. So about the Yamanaka factor research, but again, I'm completely against all this. This is like so dangerous. So, however, this technique poses risk when applied in vivo, such as loss of tissue identity, formation of inappropriate cell types and tissues, increased likelihood of genetic mutations, and risk of cancer development. Okay, so it's again people who propose this Yamanaka factors. I don't know, this cannot be used for sure. So there is an option that this opinion, there is an opinion that this process is not appropriate for an anti-aging therapy in vivo, as induction of pluripotency in the or direct injection of pluripotent cells in vivo invariably leads to cancer in mice. So it is again. It was proven in mice. It always leads this use of Yamanaka factor or injection of this pluripotent cells from cell culture leads to cancer. So patent derived this induced pluripotent stem cells could theoretically reduce immune rejection, but abnormal gene expression or mutations during reprogramming could still trigger immune responses, and again all the dangers what I mentioned. Moreover, these cells may be more susceptible to cellular senescence and premature aging. So how they do it? They take somatic cells from the donor. They in cell culture they multiply them, and they also with Yamanaka factor they reprogram these cells into this pluripotent stem cells, and then they make injection in the transportation of these cells into the body of the donor. But what may happen again, this injection of these pluripotent cells, somewhere it may lead to development of teratoma. Teratoma, it is kind of cancer, but it is very special. It is like growing of teeth inside your body where it is not supposed to be, or growing of hairs. Yeah, it is very dangerous, I believe. So it's okay. I would avoid it at any cost. I would never propose this. And okay, who works in this programming of the cells? Yeah, this teams of the people. So I work in science for a long time. Okay, and I'm professional scientist. I always was working in science. I can see from appearance of people as a talented, gifted people, as a good researchers. And I tell you what, from my experience, I just can look at the person, or better, of course, if I hear what they propose. But if I look at them, I already have an idea or suspicion that this person is going to just make some career, and he is not. He is only interested in money, and I would never trust these people. Never. Okay, sorry guys, but again, looking at these faces, I don't see any intelligent person. No one. Okay, no one. Okay. Sorry, maybe this one is better, but all the, I know, I would not, and I never trust them, and I would never rely on the publications of these people. Somatic cells can also release extracellular vehicles to expel accumulated junk, damaged DNA, and protein aggregates. Extracellular vehicles range in diameter from near the size of the smallest physically possible liposome, it is only 20-30 nanometers, to as large as 10 microns or more. Also, the vast majority of extracellular vehicles are smaller than 200 nanometers. A wide variety of biological functions have been ascribed to extracellular vehicles, including the following: eliminating accumulated trash in cells. Okay, this is how they function. This the accumulated trash and junk material just expelled from the cells through the generation of these extracellular vehicles. Okay, next transferring functional proteins from one cell to another. DNA and RNA, yeah, it's in principle, yeah, especially mitochondrial DNA can be transferred to other cells. And signaling to the recipient cells such as immune cells. For example, neurons affected by Alzheimer's disease release this amyloid protein aggregates as they accumulate this junk, and they release with extracellular vehicles this junk outside. And but again, while most efforts in research are directed on removing such amyloid aggregates, some research suggests that Alzheimer's disease may be related to insulin resistance in brain cells, and therefore this even proposed that to call it type 3 diabetes or brain-specific type of diabetes, okay, for Alzheimer's disease. I fully support this idea. Again, this sugars, they react not only with proteins, they react also with lipids, and then all this accumulation of this junk inside the cells is happening, and if it is expelled outside, then it again this or also insulin resistance develops, and brain cells cannot get enough energy from glucose. So okay, I was talking many times in my presentation about that use the ketone bodies and stay following a ketogenic diet is the best way to slow down and even to reverse Alzheimer's disease. So in old age there is no other option but to follow ketogenic diet, to my opinion. Okay, this is just schematical presentation how this aggregates of this proteins and lipofuscin goes in the brain. So this again, but yeah, people try to remove the aggregates, and of course, but again, better to avoid accumulation of this junk between the cells. It is possible again, use ketogenic diet, and it will work much better. Okay, extracellular vehicles including exosomes and microvehicles. Exosomes are small and microvehicles are a little bit larger. So they can be produced from cell cultures and body fluids, this or that. So they they gained significant attention in aging research, and extracellular vehicles can influence the behavior of recipient cells, including modulating immune responses, tissue regeneration, and inflammation, which are all important factors in aging. So it is a really interesting topic, and again, what is extracellular vehicles based therapy is offering the benefits of stem cell therapy without the risk associated with living cells transplants. Okay, this is true. I didn't go much in this, so I cannot say much about dangers or benefits of this extracellular vehicles therapy, but at least something very interesting happens. Extracellular vehicles secreted from senescent cells can promote senescence in other cells. This is how senescence is ignited. Also, extracellular vehicles secreted from non-senescent cells, from younger cells, can rejuvenate senescent cells. So again, it is very interesting, probably interesting, but again, it's this technology is not simple, and so I don't know how it will go. Studies have suggested that extracellular vehicles derived from stem cells, from mesenchymal stem cells. These cells are produced in bone marrow. They can reduce inflammation and slow down fibrosis in aged tissues. Yeah, that's again. I believe that we can get it somehow else cheaper, but yet again, interesting information that this injection of these extracellular vehicles can reduce fibrosis and inflammation in aged tissues. More research, as I said, more research is needed to develop protocols for safe and effective use of extracellular vehicles in human anti-aging therapies. Again, some people already propose therapy, and they claim that it is giving some benefits. How long these benefits are lasting, I don't know. I prefer long-lasting benefits, but certainly it is much more safe than stem cell therapy. So again, potentially this has a lot of therapeutical uses, and because again, fibrosis develops everywhere, inflammation develops everywhere, so it can be interesting area of research. But again, these stem cells are produced in bone marrow, and they use this culture, stem cell culture, and then this filtrate cells and fluid. They inject fluid, not stem cells, but only fluid from this laboratory cell cultures to bodies of some people, so, or mice. Yeah, or even extracellular vehicles can be produced from body fluids. It is breast milk, why not, and semen, urine, etc. But again, or plasma, even injection of plasma also give effect. But again, this injection of young plasma definitely give short-term improvement, but it is only short-term improvement. So I think it is interesting, but yet it is expensive, and more research has to be done. So I would not advise it, but research can go in this direction. Probably it is promising. Okay, you can go to the source of information, read the publications, make your own research, and if you want to support my research in my channel, okay, please subscribe to my channel, spread this information, and then also you can get a personal contact with me, and so I maybe will help something with my advice and to you more. How to connect with me, it is in the description to this video. So, and have a wonderful day. Ciao, ciao.